Okay, using the periodic table to be able to get the P, E, and N, and then dealing with isotopes from the periodic table. So we've got, we isolate the element, we look at the atomic number, and the atomic number is going to give us our protons and our electrons. And right now we look at that, unless said different, that's a neutral atom. If it's got a plus charge, if it's an ion or a negative ion, the electrons would be different, but right now it's not. And then subtracting these two out gives us, from a rounded situation here, gives us neutrons. So our P of this would be 19, and that's our positives. Our electrons, because it's neutral, 19, and then we subtract to get our neutrons, rounding that number, and we get 20 neutral. Just put a little sign as a neutral for that. Okay, so with that, I've got a couple of problems I want you to do, and this is from your work for homework. So this is 335. Actually, this is just a problem that you would eventually have to determine and do. So nitrogen itself, look at your periodic table. You look at your periodic table, nitrogen itself, if I were to round, you would have, you write this a couple of different ways, 14 and 7 or vice versa. A lot of things have it that way. So if we look at our protons, electrons, and neutrons for that being neutral, negative, and positive, this one is an easy 7, 7, and 7. Protons, electrons, and neutrons for phosphorus. You look at phosphorus, number 15, you got 15, 15, and you subtract the 2, and you get 16 neutrons. And carbon itself, protons, electrons, and neutrons. Carbon's a real simple one, 6, 6, and 6. From that standpoint, carbon being carbon 12, and phosphorus being 15, and rounding this number to 31. Okay, so let's look at an isotope. So carbon has 3 known isotopes. Living carbon, carbon 14, and eventually more light carbon, carbon 12. Carbon dating is uses this technique of living carbon and the amount of carbon left in an object once something dies, it decays. Most carbon out there, of course, is dead carbon in rock, so most of the carbon out there is 12. So carbon's atomic mass is 12.01. Very little is living carbon, carbon 14. You'd think differently of that, but if you look practically, that's the thing. So carbon 14, carbon 13, and carbon 12. Okay, so this, of course, has all of these have the same number of protons and electrons, 6 and 6, but the neutrons for each one of these will be different. Subtract the 2, this is going to have 8 neutrons. This one is going to have 7 neutrons, and if you subtract the 2, this is going to have 6, and that determines mass is different with isotopes, and your number of neutrons is different.